All right, geometry students, in Skills Practice 3.6, we're looking at the now, find the distance between a point and a line. So we make sure we're talking about a perpendicular distance. Find the distance between parallel lines is something else we'll also do. So new vocabulary is equidistant. Okay, and the words, the distance between a line and a point not on the line is a length of the segment perpendicular to the line. So when you have a point off the line, we don't measure the distance from C to any particular value. It's always going to be right where it makes a 90-degree angle. So we're talking about that's the distance we're describing. Okay, so we don't describe the distance CB to represent the length. The shortest distance between a line and this point is actually the perpendicular distance. Here's our perpendicular postulate. If given a line and a point not on the line, then there exists exactly one line through the point that's perpendicular to the given line. Okay, real world example number 1, constructing distance from point to a line. So a certain roof truss is designed so that the center post extends from the peak of the roof at point A, okay, to the main beam. Construct and name the segment whose lengths represent the shortest length of wood that will be needed to connect the peak of the roof to the main beam. So there's my main beam. Okay, and so the distance from a line to a point not on the line is the length of the segment perpendicular to the line. So that's why we have that right angle here. Okay, and we're going to locate points R and S on the main beam equidistant from point A. Okay, locate a second point not on the beam. So we end up using a compass, and we can find this point and this point, okay, making equidistant. So we move our compass over and we mark the 2 points, and then we're going to construct the line AB so that AB is perpendicular to the beam. So we start with the value and we draw our line in, and when you have our perpendicular, so locate a second point not on the beam, equidistant from R and S. And so we use a compass and we create then this point here, and then we connect the points here and here. So again, let's think about how this works, right? So we have a point off the line, and we use some type of compass to create, and it has to be long enough to cross the line. So we cross here maybe, right? And then we cross here. And then we choose another distance, or the same distance even, and we choose our points. And then we do the same thing here and here, and then we connect the points, and we have our perpendicular line. The measure of AB segment represents the shortest length of wood needed to connect the peak of the roof to the main beam. Okay, which segment shows to the shortest distance from point A to DB? Go ahead and pause your video. Well, it has to be that right angle, right? Therefore, it has to be the AX, the distance AX. Okay, in coordinate geometry, line S contains point 0, 0. As we can see, it goes through the origin. And negative 5, 5. That's also a point. Looks like right here. And we're going to find the distance between line S and the point 1, 5. Well, again, what you want to think about is we need to know the slope, right, of this line, right, of our line that contains the origin negative 5, 5. And we're going to take the negative reciprocal, so we need to know then the slope of this line here. That's the perpendicular. And then we're going to find that distance. All right. So step 1 is find the slope for line S, as we said. So we can use the two ordered pairs we have, 0, 0, and negative 5, 5. Okay? And that's pretty simple. We can find out that that slope's negative 1. So my slope is negative 1 for line S. Therefore, we're going to be writing that in our slope-intercept form. Then write the equation of this line by using the point 0, 0, which makes it nice and simple. And we have y equals negative x. Y equals negative x then is the line S going through the origin. Then we're going to write an equation for the line perpendicular to line S315. Well, we know if the equation here has a negative 1 slope, then something perpendicular is going to have a positive 1 slope. So we need a slope of 1. And then we're going to use the point 1,5, and we can easily put this in our point slope form. Y minus 5 equals 1 times x minus 1. We can distribute, and we get x minus 1. And then we're going to bring over our plus 5. And so that we can have our equation. We end up with then y, then our line, we're calling it t, is equal to x plus 4. Okay, now what are you going to do with these two lines? We have a line called x plus 4, and we also have a line called y equals negative x. Well, what we need to do is take these two equations and set them equal to each other because they're both equal to y. So we can actually take these two, and in this case what they're doing is they're just going to add the two equations. That's probably the easiest way of doing it. And the x's are going to cancel, and you get 2y is equal to 4. Another way of doing this is to take your two equations, negative x, and set it equal to x plus 4. And therefore we get negative 2x is equal to 4, x is equal to negative 2. Okay? So we get y equals 2. And then once you have y equals 2, we're going to solve for x, and therefore we get x equals negative 2. Okay? But I solved it this way first for x, and then we'd solve it for y. But in either way, you'd get the ordered pair negative 2, comma 2. And this is going to be the point z. This is where the two lines will cross at that right angle. So now we're going to use the distance form to determine the distance between 1, 5 and negative 2, 2. Okay, well, remember the distance formula. The difference in the x's, right, the delta x, that's 3. And we're going to square that and get 9. And then we're going to say the distance between 2 and 5 is 3, and we'll square that and get 9. So it looks like we get the square root of 18. Or we can use our calculator and say it's about 4.24 units. Alright, so this one might take you a little while, so I want you to check your progress. If you have to, go back and look at the video prior, and you're going to find the distance between this point B, 3, 1, and and our line N. Go ahead and pause the video and try to find the distance. And we end up with a square root of 8. Okay, distance between parallel lines. Now, the distance between parallel lines is the perpendicular distance between one of the lines and any point on the other line. Because when you have lines that are parallel, you can pick any point on here. This distance here would be the same. Okay. Two lines equidistant from a third. In a plane, if two lines are each equidistant from a third line, then the two lines are parallel to each other. Okay, so distance between parallel lines. Find the distance between the parallel lines A and B, whose equations are 2x plus 3 and 2x minus 1. Now, you'll need to solve an equation to find the endpoints of the segment that's perpendicular to both A and B. From their equations, we know that the slope of the line A and B are both 2. So, we're going to be sketching a line P through the y-intercept of 0, negative 1, perpendicular to lines A and B. Now, since we have a slope of 2, we're definitely going to have a slope of negative 1/2. So going back, our little dashed line, right, has a slope of negative 1/2. Okay, now that we have, we're going to use the y-intercept of 0, -1 as one of the endpoints of the perpendicular segment, and we're going to come up with the equation using our point-slope form. And so in this case, we end up with y equals negative 1/2 x minus 1. Now what are you going to do with this negative 1/2 x minus 1 is we're going to use a system of equations to determine the point of intersection of the lines A and P. Okay, so again, we got two ways of doing this. You could do substitution and say 2x plus 3 equals negative 1/2 x minus 1. Okay, that might be one way of doing it. If you notice this time, if you add the equations, nothing cancels. Unless we double the bottom equation, we could try that, and we'd get 2y. Let's see what we're going to try here. Okay, so we're going to substitute. Okay, so they're going to just take the route that I did on the first example and substitute 2x plus 3 in for the y on the second equation. And then they're going to add half an x and subtract 3 and then divide. And that we end up simplifying, and we end up with an x equals negative 8/5 by multiplying each side by 2/5. Okay, now what we're going to do is we're going to take this negative 8/5 and plug it in for the x in the equation for p. And you end up with a y coordinate of negative 1/5. So we have a point of intersection that's negative 1.6, negative 0.2, or negative 8/5 comma negative 1/5. All right, now we still have a little bit more to do. Now we got to use a distance form between these 2 points. And so we could say that the x coordinates are about 1.6 apart. Okay, so 1.6, and we're going to square that. And then we're going to add to that the distance between negative 1 and negative 0.2 would be 0.8, and we're going to square that. And then we're going to take the square root of the whole thing. So we use our distance formula, and there it is. And we end up with 1.79. So the distance between the lines is about 1.79 units. Okay, so here we go. Find the distance between the parallel lines A and B, whose equations are y equals 1/3 x plus 1 and y equals 1/3 x minus 2. So again, you can pick any point on one of the lines, right? And figure out a line perpendicular to it. Find the point of intersection, and then use the distance formula. I'm going to pause the video. You should pause the video to try this problem. This might take you a minute or so. So please pause the video. And the answer ends up being 2.85 units.